section, but we're not gonna do all those word problems, there's just too many. What we wanna do is, in your notes, we left off at the end of number 3 last time. I'm gonna skip 4, and we need to do 5. We need to talk about the sum of the infinite series, okay? Now, we have our formulas.
We have to memorize them?
You know what, I keep forgetting to ask, let me make myself a note.
Me too.
And I will ask.
There's no way we can memorize all of them.
There's only 5 of them. She could find it.
Only?
I got one right.
I haven't
She said one right. She said it all.
I need a day today, I want to email you the answer.
Alright,
All right, find the sum of the infinite series. This right here is the formula for the sum of an infinite geometric series. If you recall, this was the formula for a regular geometric sum. Now, if something is infinite, that means it's uncountable, right? That means that you can't have an n, because n is like the number of terms, like n or a sub 50 or s sub 50. So if you take this formula and take out the part of it that involves an n, you have the infinite formula, okay? So you see how it's there? It's the infinite formula. This is for an infinite. So if we look at problem 5a, first thing you have to do is figure out what is your ratio. So what do we keep multiplying by? 0.5, 1/2 or 0.5. So your answer to part 5a would be 3 over 1 minus 1/2 or 1 minus 0.5, which is going to be 3 over 1/2 or 3 over 0.5, which is 6. So the sum is 6.
so that's a geometric equation with the n?
Yes.
And without
Yes. All right, let's look at number 4, or B, I mean, look at number B. Okay, let's look at it. What have we got?
It's dividing by 2. Or no, it's going negative to positive to negative. Or the positive to negative.
So what are we multiplying by?
Negative 0.5.
Negative 0.5 or negative 1/2, however you do it. So 4 over 1 minus negative 1/2. So 4 over 1.5, right? Which is what? 8/3? Remember, we aren't having decimals unless we have to have decimals. So when you type that in,
Do calculators the entire time.
yes, when you type that in, you get 2.6666, so you hit math graph, and it gives you 8/3. All right, C.
Maybe like 2/3.
What are we multiplying by?
Or maybe 4/3.
3/4?
Well, you can check it easy enough. What's 6 times 3/4?
18/4.
Or 9/2? So is your second term 4.5? Nope, so it's not 3/4.
It's 3 over 2
4/3.
to the something.
2/3.
Oh, 2/3. Let's try 2/3. What's 6 times 2/3?
4.
4. Oh, that's what I want. What's 4 times 2/3? Which is what I want. So it looks like my ratio is 2/3. So we have 6 divided by 1 minus 2/3. 6 over 1/3, which is 18. 18. Can you figure figure out your ratio in problem D. Times what? Well, if I do 3 times 1.25, I do not get 4.5. 1.5, 3 times 1.5, 4.5. So the ratio is 1.5, or 3/2, 1.5. Now, here is something I didn't share with you, and none of you asked. I know it's Monday, I know you're counting down the days till you don't have to come to high school anymore, but no one asked about, wait, Mrs. Ford, these things are infinite, and you're adding them up? How can you do that? I mean, think about it, it goes on forever and ever and ever, and I'm adding them up and coming up with a sum? How in the heck can that be? Well, I'll tell you, it can't be, it can't happen if the terms are growing. Ellen, what are you doing? No, that's not good. We don't want to do that. He's on his watch. We don't be on our watch. If the terms of the sequence are growing and growing and growing and growing and growing forever, you can't add. So the last problem, D or whatever it is, D is not addable. Because in order to use this formula, the ratio must be less than 1. In other words, you have to have decay. You can't have growth. And that last problem, those terms are growing. Okay? So don't let me trick you. You can find the sum of an infinite series that is geometric decay, getting smaller, multiplying by 1/2, multiplying by 1/3, whatever. But as soon as you start multiplying by 2 or 3, you cannot do it. All right, so no sum. That last one, you write can't do or no sum or something. Not summable. All right, so did everybody hear me say that? So when you find your R, if it's bigger than 1, done.
No good.
If it's less than 1, you're going to use your infinite formula. Okay?
Well,
Yes.
so it's no solution?
Yes, can't do, no solution. All right?
Wait, so,
Now, I wanted you, just so you can see how it works, I'm gonna do a random word problem. So in number 7, let's do, let's just do problem D. So in number 7, I just want you to see how these problems can be incorporated in a word problem. So we'll do D. Trey's decided he'll begin saving money every day. He sets aside 40 cents the first day, 46 cents, 52 cents, and so on. So you can see what's happening here. What is this?
Went up by 6.
It is, so what kind of sequence? It's arithmetic.
Oh.
And my 2 arithmetic formulas are these. Oops. So even if I give you the formulas, kids, which I think I'm going to, I think that's what we're going to do, but even if you have them given to you, you're not going to be able to use them if you don't know what's what. So this is arithmetic and this is arithmetic. If the other 3 formulas you have, including the one I just erased, all have R's. If they have an R, they're geometric. Okay? These don't have R's. Okay, so what am I doing now? How much will be set aside on the 37th day? So doesn't that mean I want the 37th term? Right, guys?
Yeah.
So, according to my formula, the 37th term is 40 plus 6 times 36. So, 256. Remember, the unit on those was cents. So we'll say $2.56. And then question B, how much will he have set aside after saving for 100 days?
100 turn 99.
Okay, so Elijah says find the 100th term. Which I can do, but I'm not sure that's the answer to the question. That's 634. Did anybody notice anything about the grammar in the question? How much will he have set aside?
Oh, so 100 and 101.
No. Doesn't that mean how much will he have altogether?
Yeah.
How much is in the piggy bank? So this is how much he put in the piggy bank on day 100. But the day before he puts them in, and the day before he puts them in, so there's 100 days worth of saving. So question B really wants to know, what is the sum of all those days? How much will he have set aside? How much will he have saved altogether? So that formula says 100 over 2. First term is 40. And the reason that I went ahead and wrote this down is because I knew I was gonna need it. The formula needs the 100th term. So I needed to do this anyway. It's not the answer, but it's what I'm gonna put right here. Now I can see how much you'll have saved. Well, oh, wait, so the answer is $337 actually, even.
Can you explain that again? Like why do you?
Because every day you put a different amount.
Because the question says, how much will he have set aside?
Yeah, we found
It doesn't say how much will he set aside on day 100. It says how much will he have set aside.
So another 100 days.
No, we have
That's the first 100 days. How much has he done in the first 100 days? This totals them all up. That just finds the 100th day.
Oh, I see.
So it's like one every single day. We found one day we would find every single day.
Yes.
It means how much did he make? How much did he make on the 100th day? Not how much.
This is how much you save on the 100th day. This is how much he puts in the bank on the 100th day. This is how much he has put in over the course of 100 days.
It's so loud.
All right, let's do one more word problem. Let's try G. Word problem G. All right, here we go. Michael had to do 5 problems on day 1, 9, 13, and so on.
So it's like infinite.
If Michael did 538 problems on a certain day, did he stick to the plan? So in other words, we know this is the plan. This is arithmetic.
Yeah,
each day he's gonna do 4 more than he did the day before. So the question is there eventually gonna be a 538 in his list of problems? That's the question. So how can we tell? Well, this is arithmetic, right? And I wanna know, is 538 going to end up being an answer to one of these problems? Like 634 was an answer here, and 256 was an answer here. Will 538 be an answer? Well, the first term is 5, the common difference is 4, and I'm gonna solve that. I'm gonna see what that answer is. So I'll subtract 5. I'll add 4. Divide by 4. Exactly, Elijah.
Show me.
I got 134.25. He didn't follow the plan because n is first term, second term, third term. N is a whole number. When I worked it out, I got a fraction, a decimal. Right? Which means 538 is not a term. So he did not follow the plan because n didn't turn out to be 134 or something like that. Okay? All right. I am happy to do any of the rest of those you want to. What I want to do right now, though, is, are there any questions? I've given you back a bunch of homework, I've marked things off and whatever. Are there questions you have about any of that? While you are sorting that out, I'm gonna give you your review sheet, which you will need to do on other paper because I crammed them in here.
Bro, this is my only couple papers I got.
We'll see if he actually
Everything
does.
else is
He might be late. He'll wander across the thing. He's just gonna finish this thing. You're just walking in front of him. Dr. Bridges is gonna be up there plugging his It could be like, put his headphone in. Yeah, he's gonna have that.
All right. Does anybody have a homework question you want to address?
It's actually a question right here too. Is number 9 expand 2x plus 1?
Okay, so we'll start with number 9. On the review sheet, we're expanding this binomial. Okay? Now, first thing I do when I expand is, because I'm going to have a bunch of terms with the cross, I figure out what are going to be my coefficients for those terms. Anybody remember how we get the coefficients for the terms?
Oh, you made the
I
triangle.
use Pascal's triangle, so 1, 1,
Airball.
and since I am expanding to the 5th power, I use the 5th row. So my coefficients are 1, 5, 10, 10, 1. So I start by writing those down. Each of these is going to have a term, so there's going to be 6 terms. Now what? All the terms have a coefficient. What else do all the terms have? They all have a 2x. Gotta be in parentheses.
Y.
And, oh, yeah. And they all have a y.
A lot of stuff. And then you go forward or
Alright, so let's stop right there. Elijah, I get my numbers written down, my coefficients written down. Everything gets a 2x and a y.
and you put your
And then I put my powers on,
5, 4, 3, 2,
starting
1,
here
yeah.
with 5, 4, 3, 2, 1, 0.
And then 5, 4.
Why now is me? Now it's me.
2, 1, 0. Now each of these is a separate term. So I'm gonna go ahead and put pluses in there to separate them. And then the only thing left to do is to simplify each one.
Cross out the 2x.
Anything to the 0 is 1.
2x.
This is gonna become 32 x to the 5th. Plus, now be careful, that's a 5, but this is a 16. So that's gonna be 80 x to the 4th y. That's a 10, but this is an 8. So there's another 80 x cubed y squared. There's a 4, so that's a 40 x squared y cubed. That's just 10 x y to the 4th. That's gone, so the last term is just y to the 5th. Okay, all right. Anything else from a homework or this sheet? The sheet does have some problems on the back. So anything else? Yeah.
On 9-3, homework number 2, can we do question 2?
9-3, homework number 2, which question?
Question number 2.
2. The one about the grades?
Yes.
Okay. So now I'm doing 9.3 homework number 2, problem 2. We have alright, so I have 34 kids. And they're getting A's, B's, and C's. 7 get all 3s, so I'm gonna put those right there in the middle. 5 get all A's. 2 get all B's. Can I see your paper, Vincenta?
Yeah.
Because I left something out of the problem unless I included it.
Where that?
Oh, yeah, I did. Yeah, I retyped it, so I don't have to. Let me borrow this for just a quick minute.
And Bayer.
So, 5 get all A's, 2 get all B's, and 4 get all C's. Okay. 18 students get A's. So 18 get A's, 22 get B's, and 20 get C's. Okay. All right. Okay. So, I don't know what these little missing pieces are, so I'll call them X, Y, and Z. So 12, X and Y and 12 have to add up to 18. These are the kids that are getting A's. So 12 of them are already counted, and then X and Y. And then I have here my B's, so Y, Z, and 9 have to add up to the B's, which is 22. And X and Z and 11 have to add up to 20. stop right there. Does that make sense to you?
Yeah.
Okay. So I'm gonna clean this up a little bit. X and Y add up to 6. Y and Z add up to 13. And X and Z add up to 9. Now, my suggestion to you is just pick 2 of the equations and eliminate something. So if I just go with the top 2, I would be eliminating Y, okay? So I'm just gonna do that, eliminate Y. So I add those together, I'm gonna get X, these are gonna cancel, minus Z equals -7. And then I'm gonna combine that with this bottom equation, because it has the same variables, X and Z. So when I add those, 2x equals 2, so it looks like x equals 1. Now I can either use my picture, or I can go back to my equation. If x is 1, y is gonna have to be 5. And if x is 1, z is going to have to be 8.
You find one, just find one.
Yep, just find one, yep. So the question is, what's the probability that he gets no A's, B's, or C's? So in other words, there's 34 kids in the pot, and we've got represented up here, we have 18, 28, 32. So there's 2 kids out here that get D's and F's. Now this is a probability question. So it'd be 2 out of 34, or 1 out of 17, because it's a probability question. And then what's the probability he gets only A's and B's? So if you look up here, only A's and B's is where on this? Isn't that right here? Because if you, this guy gets A's and B's, but he also gets C's. So 5 over 34.
Whoa.
Well, 34 is 34, and then she calls out all these. Like, all of them? Yeah. 5 4s, 2 7. Yeah, and then whatever you don't, whatever, like, it's like that.
All right, who else? Homework question or from the review sheet? Come on, we're gonna use our time wisely. We only have one more review day and the test. Tyler? 9-2, question 3, homework. Homework, 9-2, question 3. The baseball player problem? Alright, so the probability of a hit is 0.234. So that means the probability of not a hit would be 0.766. Now, I want him to go to bat 5 times and get 3 hits. Exactly, 3 hits. Okay? So think about that for a minute. I'm gonna give him 5 chances, and I'm gonna pick any 3 of them to be hits. So it could be hit, 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 not, hit, not, hit, not. You know, it could be any of those. I just need 3 of them to be hit. So I'm gonna start with that number, 5C3, which I think is 10, but I'm gonna check that. Yep, that's 10. So what that tells me, Tyler, is if I write down like hit, 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 not, hit, not, hit, not, hit. There are 10 different ways that I can pick 3 out of 5 to the H's. Okay? Now, the hit probability is 0.234, and I want 3 of those. And the not hit probability is 0.766, and I want 2 of those. So I have my individual probabilities of what I want, what I don't want. I know I want 2 of these and 2 of these. And then this is the number of ways I can make that happen. Okay, all right? Okay. Who else? From the worksheet or some homework somewhere? Yeah, Pat.
From the review, find number 12.
With number 12? Number 12? Find the 15th term of this sequence. So, I am either going to be using A sub n equals A sub 1 plus bn minus 1, or A sub n equals A sub 1 r to the n minus first. Because my job says literally, find the 15th term. So I am going to find A sub 15. So these are the formulas, these are my options. Now, how do I decide which one I need? Whether it's arithmetic or geometric. Now, boys and girls, I hope you can tell immediately it's not arithmetic, because that's going down by 10, but that's only going down by 9, and that's going down by some decimal, right?
Divisible by 9.
So it's got to be geometric. What's the ratio? 0.9. I'm multiplying by 0.9. 90 divided by 10, or 90 divided by 100, that's your common ratio. 81 divided by 90. I am multiplying by 9 tenths. I'm multiplying by 9 tenths, 0.9, 0.9, okay? So here we go. A sub 1 is 100, 0.9 to the 14th. So that would be my calculator won't change it, so I'm gonna say 22.877 is the 15th term. My calculator only gives me a decimal.
Oh,
You don't want us to put that.
okay.
If your calculator will do it, put it as a fraction, but if it won't do it, then it's gonna be a decimal. Yeah.
You know, we're 15.
Okay, is this all right?
Yep.
Pat, you got it?
Yeah, why did you get to the 14?
Because the formula says n minus 1. All right, which one, Jake? 15. So I have 3 red, 5 green, 8 blue. I want to get 2 red, 1 green, 2 blue. How many ways can this happen? Well, we did problems like this before. I can't remember if they were boys and girls or Republicans and Democrats or hearts and spades or something, where you've got different piles and you're choosing from those different piles. So I have 3 reds and I'm picking 2. Just like if I were picking 2 queens out of the deck, it would be 4C2, because there's 4 queens picking 2. There are 3 reds, I'm picking 2. All right, then what's this one?
5 greens picking 1.
5C1
And 8 blues are picking 1.
and 8C2. Now, what do I do with those 3 numbers? You can type that in and that in and that in, they're all nice little numbers. What do you do with all of them when you get them? Multiply. Because you are doing red and green and blue. And means you multiply, or means you add. This is and. So we just multiply those 3 together. So 15 times 28. I got 420 as my answer.
Is that all?
That's all, that's the answer. How many ways can you do it? 420. All right, who else? Something.
Number 1 for 9-4 homework.
9-4 homework. Number 1. This sequence is expressed recursively. So our formula for the sequence is this. And we know a sub 1 is 2, that's given. So we have to work our way down all the way to the 5th term. Here's the deal, Pat. If I just said I want your 5th term, and according to my formula, I would have to let n be 4, right? So then my formula would say 4a sub 4 minus 3. Okay, but I don't know the 4th term. So then when I get this one, it would be 4a sub 3 minus 3. See, I don't know that. So I just gotta start at the top and work my way down. So the second term, if this is gonna be 2, the second term is gonna be 4a sub 1 minus 3. But that's 4 times 2, I do know that one, minus 3, so that's 5. Now I know my second term is 5. So what's my third term gonna be? My third term is gonna be 4 times the second minus 3. And then 4 times the third minus 3. And finally, 4 times the fourth.
257.
257. 2 times 65 minus 3. When you have a formula that's written like this, it's called recursive, and you can't skip ahead. You have to work your way down to the one that you
You just
want.
multiply the last term.
What?
You just get the answer, you multiply.
All right, who else?
Can you do number 1 of 9.3, number 2?
9.3, number 2, number 1, the cookie problem.
Yeah.
All right, we have 2 cookie jars on the counter. A blue one and a green one. Okay, so I got a blue and a green. The blue one contains 6 chocolate chip and 8 sugar. And the green one contains 2 chocolate chip and 5 sugar. Are you okay with my, picture of the situation?
Yeah.
Okay. So, how many cookies are in the blue jar altogether?
145.
14.
Oh.
How many are in the blue jar?
Oh, my bad.
14. So the probability I'll get a chocolate chip one is 6 out of 14. I know that reduces, but 6 out of the 14, and this is 8 out of the 14. And then over here, there's only 7. So this would be 2 sevenths, and this would be 5 sevenths. So I might as well reduce these. This will be 3 sevenths and 4 sevenths, okay? Now, when I walk into the kitchen, or Declan walks into the kitchen, what is the first thing he has to decide? He wants a cookie. What's the first thing he has to decide? Am I gonna go blue or green? And he's got a 50-50 chance. So the probability he'll pick blue is 1/2, and the probability he'll pick green is 1/2. Then, he's picked a jar, he reaches in and grabs a cookie. What is the probability that the cookie he gets is a sugar cookie? Well, he can get a sugar cookie out of the blue jar, so that would be 1/2 times 4/7 sugar out of blue. Or he can get one out of green, which would be 1/2 times 5/7. So this is 4/14, and this is 5/14. So the probability that he's gonna get a sugar cookie is 9/14. All right, then, what is the probability that is a chocolate chip cookie? What is the probability that if it is a chocolate chip cookie, it is from the blue jar?
0.5 times.
Okay, so wait. That is, what is the probability that it's from the blue jar, given it's a chocolate chip cookie? So what is the probability that if it is chocolate chip, so given that it's chocolate chip, what's the probability it's from the blue jar? Okay, so our formula for that is probability of both over probability of just C. So whatever the given is, always remember, whatever the given is, that goes in the denominator. So given that it's a chocolate chip cookie, probably that if it's a chocolate chip cookie, given it's chocolate chip, that's your denominator. And then both is the numerator. So what's my numerator? Blue and chocolate chip would be 1/2 times 3/7 out of the blue jar and chocolate chip divided by the total chocolate chip, which is that number again, plus 1/2 times 2/7. So that's 3/14 over 3/14 plus 2/14. 3/5. The answer is 3/5, 60%, 3/5. Ronan?
So when it's asking this, it's not asking like over all of the cookies, it's just out of all the chocolate chip
Yep.
cookies.
As it says, if it is a chocolate chip cookie, so we're not even considering sugar cookies.
Okay. And the jar just doesn't matter in this.
Yeah, no, it does, because it's from the blue jar.
But we can add from the total.
Not in the denominator,
Under the
no, but in the top, so that's what I want.
There's one specific.
Yeah.
Like it was a deck of cards.
Yeah,
I see it.
all right, what else? Come on, we got 5 more minutes. We got lots to review. Did he ask a question?
No, he told me to ask a question, but I just said, why doesn't he just ask it?
Sure, well, just ask a question.
I don't care, yeah, let's just do a problem. I don't care who asks it. From homework overview sheet, either one.
When, it's for,
Can we do 11 on the review sheet?
Yep.
They don't want that.
Okay, number 11. There are 5 people in a race. Each of the top 3 finishers will receive $25. How many different ways can the prizes be awarded? Now, you guys listen. Do you care? I mean, I know personally you would, but in terms of the prize, do you care? Does it matter if you finish first, second, or third? Not in terms of the prize, because what's happening? They all get $25. So, in terms of the prize, I mean, you have your own personal pride and ego, of course you want to win. But in terms of the prize, It doesn't matter who gets first, second, or third. I mean, they all get the same prize. So there are how many people in the race? Five. And 3 of them are gonna win the money,
Yep.
right? And the order doesn't matter, because they're all doing the same. 5, C3. 5, C3. Now, normally, in a race problem, normally it would be 5 P3. Because normally we're getting a first place trophy, a second place trophy, and a third place trophy. But here we're all getting the same trophy, so order doesn't matter. All right, stop, we're not packing up. We got time for another problem, come on. Go.
6 kids seated in a circle, it's just 5 categories, right?
Yes. 9-4 homework, problem 2. So this is a situation, hey, you guys, please, we got 2 minutes in this problem, you can do it. So we've got, the third term is 24, the fourth, fifth, sixth, seventh, 8th term is 59. And we know we are arithmetic. So that means that to get from here to here, I'm gonna be adding the same number, right? How many times am I gonna add it?
5.
5. So 5 of those additions
35.
has to add up to 35, the total distance. So D is 7. That means, going that way, I'm gonna add 7, add 7, add 7. The question is, what's the first term? So I don't wanna add 7, I want to subtract 7. So the first term is you're praying. Wasn't so Lord, and these I guess.